So in the last session, we discussed functions concept and parameterized functions also. So and how to return the values from a function, all those things we discussed. And today I'm going to explain uh, how to return multiple values from a function. Previously, we discussed one value. It is how the function is returning in one value to use in another functions. But now we are trying to explore how to return multiple values from a single function and another concept called arguments. So in other programming languages like C, C++, and Java, functions can return only one value. But in Python, a function can return any number of values. How it is possible? See, simple here. Function. I'm creating one function called def sum underscore subtraction. Function name is sum and subtraction and parameters a comma b. Now, so sum means a plus b, right? Sum variable sum equal to a plus b, subtraction equal to a minus b. So I want to return sum and subtraction both from a single function. Simple, you can use like this: return space sum comma subtraction. Like this, you can return multiple values from a function. So in what cases this kind of return values will be useful? See, the same function will be useful in different functions. In one function, you can utilize one value called sum, and another function you can utilize another value called subtraction. In any other function, if you want to utilize multiplication, you can create a value called multiplication and you can return that multiplication value in another function. See, the functions concept is started for reusability. See, the same function we can utilize in different places. That is the intention of returning a multiple values from a function to utilize in different places. Whereas compared to C, C++, and Java, you can return only one. If you are trying to return multiple values, the syntax is not support the compilation errors you will get from the other that programming languages. But Python was flexible to design to access different values from a single function. Okay, now I've created a variable called x comma y. Comma y. You can create multiple variables in one line and you can create separate lines also, because to reduce the lines of code we can declare in one line x comma y equal to sum and subtraction is a function. Sum and subtraction is a function. So here where what we passed in the function level in the line number 1, 2 arguments, right? So here I want to pass a value 100 comma 50. These are the values. So print statement, the sum is comma x. Okay, x is nothing but this x variable is it indicates a sum. Okay, and another print statement. The subtraction is comma y. So y variable is assigned to the subtraction. Okay, so now we can cross verify the output. See, the sum is 150 and subtraction is 50. How it calculated, how it accepted the two values, I mean two different values because of two return statements we have declared. So this is the way we can use two return statements. See, the same return statement you want to utilize in another function, you can create a separate function there, you can call this value. So that we will discuss slowly. So this is the way you can utilize the multiple return values in a functions concept. And so now how many ways you can declare a function? So the parameters. So as of now, we have declared two parameters, right? So how many ways we can declare the parameters? What are those? So in Python, there is a concept called arguments. Concepts called argument. These are all the functional arguments. We call it as a parameter, but there is another name that is called arguments, functional arguments. So how many ways we can declare a parameters in Python? So we are having a concept called arguments. We can declare a arguments in four ways. First one is positional arguments. First concept is positional. Second concept is keyword arguments. Third one is default arguments. Fourth one is variable length arguments. Okay, these are the four types. First one is what? Positional arguments. These are the arguments passed to a function correct positional order. Correct positional order. See, this is nothing but a example of positional arguments. A comma B. First one is what? Positional arguments. A comma B are a formal arguments where as this 150 are the actual arguments. Positional arguments in the sense we have to fix the position. If you change the order of your these arguments position, output will be vary. That is the intention of positional arguments. See, A comma B are a positional arguments. If you change the order like B to A to B, if you change B comma A, this output will be also vary, right? So because we have fixed A equal to 100 and B equal to 50. If you change this B to A, then A value will be 50 and B value will be 100. So you are doing what? This calculation A plus B and A minus B. Then A value will be 50 plus 100, 150. This is correct. The some value will be correct. And what about 50 minus 100? Output will be minus 50. So the output is changed. So because of the positional arguments. So you have to pass the proper positional arguments in some kind of usages in the functions. So that's what they declared four types of arguments. First argument is positional argument. You have to state the position of your argument. Okay, you have to declare a position of your argument in a meaningful order. If you change the argument position, I mean you jumbled it. If you jumbled it, automatically output of that function will be vary. That is the intention of positional arguments. See, the same example, I am going to change here this to B and A. Okay, you can observe it. 150, the sum is okay. Anyway, if you change the argument from one place to another place of the position of the argument, sum will be always same. And what about subtraction? Subtraction will be minus 50. How? Why it is? Because of changing the arguments. So you have to strictly follow the argument position. So the first example of the arguments is types in the types of arguments, positional arguments. This is the way you can declare a positional arguments. And next one is keyword arguments. Second one is what? Keyword arguments. We can pass argument values by a keyword. Okay, as a parameter name. So I will show you that example. Keyword arguments. I will copy that. So I'm going to comment this and I can write another program to explain this. Def wish, comma name, comma message. See, we can pass argument values by keywords. See, these are all the keywords, right? These are not a values. These are not a single character. It's a kind of word. This is also a word, right? 4 characters, 3 characters, this we can call it as a keyword arguments. And print of hello. See, name. I'm passing the argument in a print statement. Comma message. Simple. So this is said, then this is called a keyword argument. Now I'm going to call this function called wish. Okay, name equal to Python tester. Okay, something called tester, comma, message equal to. I have to pass the values of a keyword, right? So here, what we used in the positional argument, I have declared a argument arguments called a comma b, but where I passed the values while calling this function 100 comma 50. Same like as here we declared a keywords, right? Name and message. So what is the value of the name? What is the value of the message? So these keywords that I am passing through this function. Same like as here we are calling the function, right, in the line number 5. Same here I am calling the function name equal to Python tester, message equal to something called good morning. So now you can see, you can call any number of times this same function. You can observe the output. Hello Python tester, good morning. Hello tester, good morning. Because we are calling this function multiple times. In the first time we passed the values of the keywords in a different way, and second time we passed in the different way, I mean with the different data. So this is nothing but a keyword arguments while calling the functions. So here we used positional arguments, here we used keyword arguments. And what about the third one? Default arguments. See, default arguments. For this default arguments, the example should be like this. Sometimes we can provide default values for our positional arguments. We don't want to modify the value. Few of the functions we are passing a fixed variables. Fixed values. You don't need to change it. So at that time, you can use this default argument functions. See, when we are going to use these functions in our automation, while discussing about the frameworks, you will get to know. But you have to practice independently, because this is we are discussing about the programming language. We are not into, still we are not covered automation concepts. Automation tool called Selenium or frameworks. So even if I explain now, so this is the place that we are using these functions in our automation framework, you may not understand. So just listen and practice a programming language point of view. When we discussing about the automation framework, then remember, I will remember you. I will explain you while explaining the framework. I will remember you. Okay, this is the function that we discussed in the Python programming. This is the position there. Here we are using the functions. Okay, so default argument. Third one is what? Default arguments. So we can provide default values to our positional arguments. Sometimes we cannot change it. So here function name equal to guest. Name equal to guest, print of hello, comma name, comma good morning. Simple. So now I am going to call this function, right? So what it is asking, what the function is asking, see, I am just I'm not providing any value here. I'm going to execute this program. See, hello guest, good morning. The name value automatically it was taken as a guest, because we are not provided anything here. So now I'm going to change the name value to tester. Hello tester. Otherwise, if you are not provided any value while calling the function, it will automatically take this default argument. That is the reason we can call it as a default arguments. Okay. So you can fix this argument. Always it will print, always whenever you are calling this function, it will print this particular default argument. Okay. So, but if you want to modify the default argument value, you can pass the argument value through a function calling like in the line number 16. Okay. So the fourth one is variable length arguments. what is called variable length arguments. So these are all the three types of arguments that we discussed now. Our last one is variable length arguments. Variable length arguments are nothing but sometimes we can pass a variable number of arguments to a function that we cannot uh, decide, right? Sometimes from the database we are getting 10 values, sometimes we are getting 4 values, sometimes we are getting 1 value. So that depends upon the method construction in the backend. So then the methods parameters are the function parameters. Yes, here it should not fix the parameters. So at that time we can use this variable length arguments. Means we don't know how many variables we are getting from the backend. So at that time we can choose this option. We are having 4 types of functions create at the time of creating a function. We are having 4 types. First one is positional argument, second one is keyword argument, third one is default argument, and fourth one is variable length argument. The remaining 3 were fixed while providing the arguments. You can see these are the fixed arguments, but we have changed the position, and this is also fixed argument. Okay, we have provided the keywords. 2 arguments or 2 keywords we are using, and here we using a fixed argument called only one. Okay, so the coming to fourth one, it's a variable length. So here we don't know the input. So in this situation, we can use like this. So we can declare a variable length arguments with the star symbols like this. Def function 1 of star n. See, we can provide any number of arguments. This star n can be handle it. Okay, this is called variable length arguments. Now we will run one program. Okay, by using this variable length arguments. So I want to add. Okay, I want to add some values. Some values. I don't know how many inputs I'm going to provide. I will provide 10, or I will provide two values. I mean 3 values, 4 values, 5 values, n number of values. So star n. Okay, this is my requirement. Now total equal to 0. Initially, I'm declaring output value total equal to 0. So I'm going to write a loop for n1 in n is nothing but list of values. Okay, so total equal to total plus n1. Okay, I'm going to add each and every value to the output variable. So now print of the sum equal to comma total. So now you can observe here. So now you can observe here. N is nothing but what? This one. Okay. From where we are giving this n? From the function only, because we are not declared anywhere n. You can observe. For but we have used a loop called for n1 in n. In is a membership operator. N1 is a each value available in the n. Where here n is what? A argument. Okay. So how can we provide the n here? From the function, right? Sum of n. So initially I'm not provided anything. Okay. Initially I'm not provided anything. You can observe sum is equal to 0. Because see, then what will happen? Once we provide the n value here, that n value is this. Okay. N in n1. Then immediately n value will be what? 0. 0 is substituting in the n1. So total equal to 0. 0 plus n1. N1 is also a 0, right? 0 plus 0. Finally, total value will be what? 0. So the total will be placed here. Output variable, it's a 0. Now I'm going to pass another function. Same function, I'm going to pass a different set of values. Because star n means you can pass a number of values. So now I can use 10 comma 10. Okay. Initially, I have provided a 10. What is the output? 10. Why? N value will be 10. 10, 10 in n1. So what is the n1 value? 10. Okay. Total equal to 0. 0 plus 10 means 10. Then the total value will be what? 10. Okay. Next time I'm going to provide 10 comma 20 comma 30 comma 40 50 60. Here sum of 10 comma 20. Here sum of 10 comma 20 comma 30 for some 40. So you can observe the differences of calling a function. But in the previous example, so you cannot modify the parameters, right? You cannot modify the arguments for a function. So if you declared here in the first example 2 arguments, you can provide only 2 arguments. If you want, I can run this. It will throw some exception. You can see this first one. See, here we have passed 2 arguments, comma b. But now I'm going to pass 50. 3 arguments I passed. You can observe it. See. Type error sum and sub function takes 2 positional arguments, but 3 were given. We have declared 2 only, but why you are giving 3? I'm not able to understand. I cannot execute this. That's the reason it is throwing an exception. So, but now coming to this example, the difference between the positional and default keyword arguments, this variable length arguments is this. So you can provide n number of arguments. If you see, initially it is I have provided 10. Now in the line number 26, I have provided what 10, 20, 30, 40, 60, 6 arguments. So initially n value will be what 10. So total value will be 10. So next time 20, 10 plus 20, 30. Next time like this, it will be calculated. You can observe here. See, some value will be 10 here. Okay. Next time you can calculate this all these values. So what is the value here? Output value 210. And what about this sum? 30. What about this sum? 70. So how it is calculated? But even though if you are not provided, see, I don't have a guarantee to provide the input parameters here. That is the reason we are providing n number of parameters. We are dictated like a star n. Star n is nothing but variable length arguments. You can give any number of arguments, the function can accept it. Okay. In other programming languages, there is don't have a structure like this. So you have to write bunch of code if you want to declare this kind of variable length arguments in Java and other programming languages. Because of the Python is flexible to write a simplest logic. Okay, when compared with any other programming languages, it's a very easy and concise logic. You can easily understand and you can write it whatever you want. You think for example, you are trying to do some mathematical calculation using Python program. You want to write some program. Whatever you are thinking, I want to create a for loop. I want to create a mathematical calculation. You can write it if you know the syntaxes, all of those functions and all those things. But in other programming languages, you have to follow so many syntaxes and the proper rules that following by the underlying programming languages. But when compared to Python, it's not required. You can write it directly like this. You don't need to declare a class. You don't need to declare a function, nothing. Directly you can write it by using different programming methodologies. Basically, this is a functional oriented programming. The same functional oriented programming we can use in C, C++ also. Okay. This is a functional oriented. But if condition, for loops, so those are all see. This 3 lines is related to procedure oriented programming. So loops, conditions, all we can call it as a procedure oriented. But this line number 18 and 19, this is related to functional oriented. You can mix any kind of different programming languages here. So next one is after variable length arguments, there is another concept called keyword variable length arguments. Keyword. In case, see these we can call it as a list, right? What is the difference of list, tuple, set, and dictionary? Just kept these 3 aside. Like list, set, tuple comes under one category. Dictionary comes under another category. What is the difference between these two? List, tuple, set can accept the values or data or objects as independent, right? Individual like this. But coming to dictionary, how can it accept the values in the key value pairs, right? So how can, if you use the key value pairs in our project, how can you handle in the functions? Let's say this is accepting a independent values, individual values or objects. See, objects, values, data, all are similar words. Depends upon the programming languages, methodologies. We can use these words. Okay, don't confuse on this. When I am explaining about OOPS concept, so I can call these values as objects. Okay, so this if this variable length arguments accepts individual objects like list. Let's say this is a list. Let's say this is a tuple. Let's say this is a set example. But what about the map? I mean, sorry, dictionary. How can you accept it? By using what double star keyword arguments like this. I am going to explain that program also. Just put a comment. This is a keyword length arguments, right? Variable length arguments we just explained. Now I'm going to explain keyword length arguments. Def display of star star kw arcs. Star star kw arcs. Previous one is what? Star n. It's individual object, but here key value pairs. So now I'm going to use a function called for k comma v in kwarts dot items function, which is available in the dictionary. Okay, print of a comma v. Display is the function. See, display is the function. Here I'm going to provide what 111 is employee number. Okay, employee name. Okay, automation or employee designation tester. Okay, comma 112 equal to software engineer, comma 113 equal to admin, comma 114 equal to database developer. Okay. Some errors are getting comma it is hitting errors. Okay. One, two, it is showing that neutral. Expression cannot contain assignments. Perhaps it, okay. Run it and equal the data like this. And 1 equal to 10, and 2 equal to 20, and 3 equal to 30, and 4 equal to 40. Okay. Previously it was some literal issue. So anyway, you can use anything. So you can observe the output should be like this. So here in this example, you can observe this is a normal keyword length, normal variable length argument. The output should be print individual objects. But here, if you use this star star kw args, means it's a keyword length argument. So if you use this, the output be printed in the dictionary format. So you can provide the dictionaries and you can call the dictionaries a dictionary method like this items method, and you can call the output. So this is also another way you can declare a function. See, these are all the 5 types. I explained initially 4 times, but this is subtype is available to access the dictionaries in a functions. So this is nothing but functions concept in Python. See, these functions you can use in our programming wherever we require to reuse it. See, for example, I did one mathematical calculation in one function. How can I reuse this function in another function? By calling the function name, right? Now I'm going to explain how can we reuse that. The major intention of and usage of functions is what? Reusability. Once we declare a function, we can reuse it in another functions. So how can we achieve this with another concept called modules concept? I will explain now. Before going to that, there is a separate predefined functions are available in Python. Those functions are called lambda functions and as well as map functions, reduce functions. So those we may not use in our automation, but in the notes I have provided that examples and syntax also. You can go through that, but because from automation perspective, it's not required. So, but lambda function we can use, but very rare cases in the framework design level we can use this lambda function. So anyway, we are having one example in our frameworks. At the time I will explain the lambda function. Okay, so I will share that notes in anyway, you can go through that. So before going to that, we have to learn another concept called variables. See, we know about the variables a equal to 10, right? The basic thing. So how many types of variables in core Python it is supports? See, I am stretching core Python, not advanced Python. Advanced Python is nothing but oops oriented. There is a separate way you can you are having a variables. So 3 types of variables there, but in core Python you are having only 2 types of variables. One is a global variable, another one is local variable. Very simple. So for example, global variable a equal to 10. Okay, I have declared outside in a function. It's not in the function, it's outside of a function. Okay, so def f1 is my function name, colon print of a. Okay, again I am declaring another function def f2 colon print of a. Okay, now I'm going to call these 2 functions. Simple. Okay, whatever functions concept we discussed the same, it will follow the same syntax. F1, F2. Okay, I'm calling these 2. You can observe here is printing 2 times because we are calling this variable is 2 times. This is nothing but a global variable. Okay, what about the local variable? Okay, I'm just changing this to b equal to 20. Okay, trying to print b, print of b. The same b I'm going to call in another function print of b. Okay, what will happen? You can check. Name error, b is not defined. See, initially 10 got printed because 10 is a global variable. After that b got printed because of these 2 print statements. First print statements returns what? A value. Second print statements returns b value. Third print statement again return a value, and fourth print statement returning b value. But third print state up to third print statements it printed 10 20 10. Then the fourth print statement is trying to print because it is throwing an error. Name a, sorry, name error, name b is not defined. Name b is not. This is nothing but local variable. Okay, this is nothing but local variable. So this is the variable declarations in a function. So these are all the basic syntaxes and usages in a function. Previously, we discussed about the function, how many types of arguments we are going to pass a function, right? Positional arguments, so keyword arguments, default arguments, variable length arguments, keyword variable length arguments. Now we discussed about how to declare a variables in a, how to use the variables in a function. How many ways you can use the variables by using, by declaring a global and by declaring a local. So this is all about variables. Okay. Next concept is modules concept. Okay. Modules concept. What is modules in Python? What is module in Python? Now we can utilize these functions, reusability, reusability, we can utilize now by explaining these modules. A module is a group of functions, variables, and classes saved into a file. See, this delete.py is a module. This class one is a module. In Python, .python file, anything. So if this file, this, for example, if I expand this this constructor, okay, this is a constructor in Python. Okay, don't worry, this will comes under oops concept. Okay, so this constructor I want to use in class1.py, you can import it directly by using a import approaches. So we can call it as a module. This constructor is a module. This class1.py is a module. This delete.py is module. Everything in Python .py file we can call it as a module, and we can reuse that .py file contains what? See, this delete file contains what? One function, two function, one variable, two variables. You can reuse these in another class. How can you reuse? By importing them. This is nothing but a modules concept. So that's what it is showing. A group of functions, variables, and classes saved into a file, which is nothing but a module in Python. So this is all, this is nothing but a module. This is entire thing is nothing but this delete.py is called a module. Every Python file acts as a module. .python file acts as a module. So now we can write one program. Okay, it fails. I want to remove this. I can write here. Example, x is equal to 111. Okay, this is what a global variable. Now I am writing a function. Def add addition of a comma b. Okay, addition of a comma b. Okay, here print of, I can write one class, not here. Okay, print of a comma, sorry, print of the sum. The sum is comma a plus b. Okay, this is the calculation that we are doing by using this function. Okay, there is another function. I am writing def product. Product means multiplication, right? A comma b colon print of the multiplication. The product is a into b comma a into b. A into b. Okay, how many classes are, sorry, how many classes, variables, functions here? There is no class here. Okay, leave it about class. Okay, this is not a object oriented programming. Okay, this is a functional oriented programming example. So variables are there. Yes, one variable is there, x is equal to 111. Okay, methods, functions are there. How many functions? We are having two functions. Okay, how I saved here? If else dot py. So instead of this I can save like I want to rename it. Click on, right click on the file. Okay, refactor it. Select the refactor. Click on rename. I'm going to change the file name like math dot test math dot py. Okay, refactor it. File name got changed. You can observe here. Okay, it's changed. Now I want to call this in another file. Okay, create another file called, another Python file called test math test math example. Test math examples. Okay, I want to import it. I want to reuse the existing test math functions and variables in this current one. So simple import. There is a function. There is a predefined keyword. This keyword we discussed in the class. The list of 33 predefined keywords are available in Python that we can reuse it everywhere. Import is the one of the keyword. We know, right? Import means we can import the some of the files or content. Import what? See, automatically there is a math will comes like as a module. Select this. That's it. Now print of test math dot x. I want to print x value which is available in this test math. What is the x value? 111, where I am calling in another Python file. How can we provide the communication between these two files by using modules approach? Import to test math, then immediately all the test math related content, whatever it is, functions, variables, and mathematical calculations or anything the file contains, the test math file contains is available here. We can reuse these functions. We can reuse this function in the another module. Now you can trying to print this. Okay, so what will happen? You can observe print 111. How it printed? We were not declared here. We were declared in another function. So sorry, another class. So another Python file. This Python file we imported using a module approach. Okay. Now I am going to do the calculation. Test math dot add. Add is a function there, right? So previously in this example, how we used in the delete, you can observe we have created a function and we passed the variable positional arguments from the same Python file only. I am just uncommented it. You can observe here. See, a comma b or b comma a, whatever it is, the values we have passed as a positional arguments. These we provided the values from the same file only. But just observe here. I have provided the positional arguments in the testmath.py, but I am providing the values from separate file by calling this function as a, it shows what reusability of the, we don't need to, I want to do some calculation. Okay, the calculation method is, I mean, it is some method or subtraction method, production, I mean, what is called product method, multiplication method. I want to reuse it. So I don't want to write the code again and again. There is a function, there is a Python file is already there, test math Python file. It contains sum and product and a variable also. We can use them in our another class wherever we want. So simply we can import like this, test add comma 20 and 10 comma 20, sorry, print of it's not required because we already provide the print here. You can see print the sum is that will be printed here. Okay, next test mag dot product of some big value I have given here. You can observe. See, the sum is 30. 10 plus 20 equal to 30, right? So and product, right? This number and this number we multiplied. This is the output. How it is working? Because of simply using modules concept. Okay, whenever we are using a module in our program, for that module compiled file will be generated and stored in the memory level or disk level permanently, because it will use some memory. Okay, so renaming the module at the time of import. See, we import directly, import module name test math. How can we provide the alias names for that? There are some multiple ways, around 10 to 12 ways you can change your the module names. So as per their programming required, you can give like this test import, simple import test math as Vishwa. See, we'll get an exception, right? There is no test math. Now change it to alias name. I have provided what? Alias name. So this is the way you can use the imports. and no, I want to import another way. Okay, instead of this, I'm going to use import test math. This is the two ways we covered as of now. Okay, I'm going to comment this. The third way is what? From. Okay, from test math import x. Only x will be worked here. See here, test math. Okay, it is also not required. Import as so, and you can observe here. I'm going to comment these two because these won't work. Okay, this is another example. You can simply see as you imported only x value, comma. If you want to import multiple, comma, add function is also there, right? So simple. You can use. You can call this add function. Just uncomment this and remove alias name and directly call this add. You can see addition is also printed. Now, if you want to import product also by providing this, this is the three ways. So, few more ways are there. You can try it. I will provide in the notes. Okay. So, you can import the aliases like in the modules. Okay. This is the way you can use the alias names. Okay. While import the modules. So, from one function to another function, like from one file, one module to another module file. So you can use like this. See, the same test math.py containing what? One global variable and two functions that we are utilizing in three ways to by using this modules imports concept. So this is nothing but modules concept. Okay. See, when this modules concept will be useful in the real time, you are importing. See, I will show you one real time example in the framework level. So don't confuse by saying that. You can check. This is a PyTest framework. Okay, and where is the test case and new parts order? See, this is nothing but usage of modules from objects. Okay, from see, from page objects dot add parts order import add new parts order. This is the way we can use in real time. This is the actual real time automation script will be happening. Okay, we will discuss later. So like this we can utilize this import yeah, like modules concept. Okay, so we are having a some predefined modules is also available, something called math module also. I will show you the math module. It was designed by the Python team. Simply like from math, see, there is a module called math. From math import star. Okay, so print of square root is a function which is available in that math module. Or okay, next print of floor division of some value. These are all the inbuilt functions they provided. N dot 1, you can observe square root of 4, 2.0 floor division. Okay, if I change it to 256, it will come 16.0. See, where this square root function is available under this math module. If I click on this math, this is the module. It's a showing it's a Python file, but internally we can, it's a Python file, but internally, okay, we can call it as a module. Each and every Python file is a module. This was designed by the Python team. Okay, you can observe these are the functions they are used, they defined. So you can, if you want to, you can modify this math file, but you need to develop a separate function. Okay, so if you very good at mathematical, so you can develop your own function and you can provide this library. So Python people will allow your modifications at the Python programming level. So you have to post in the Python community team by modifying this math file, and they will analyze your requirement. They will analyze your function, and if it is a valid function that is useful for a mathematical calculation, they will add this in future references. You can and then you can download the latest version of Python. Your function will be there in the math.py here. So like this, if you want to modify this math function module, if you want to modify it in your application requirement, you can modify it. You can modify this and save it automatically. This function you can call wherever you want. Like that, you can create your own modules. The programming language, this Python, will allow that modules to modify the programming language, but it needs to be work. It needs to be properly useful for others also. So that's a different story. So this is called math. Sorry, modules. Okay, predefined module called math. So many modules. We are having random module, random functions, so many things. So that will basically use internally programming point of view. Okay, this is all about modules function. So anyone is having any doubts, you can ask so that we can close the session. So tomorrow we will start OOPS concepts. Okay, core Python is completed. We will start object oriented programming in Python. So inheritance, polymorphism, abstraction, interfaces, abstract class, object, how to create a class, how to create an object, all those things we discussed there. Constructors, all those things. So uh, until this is our core Python. Interview point of view, most of the people will ask core Python logics like this. Create a function, reuse the function, create the function which contains, I want to print a odd numbers by using function approach, by using loops like that. So please practice all these sessions. Whatever we discussed as of now, it will cover. I covered most of the concepts which are using in automation. So yeah, that's it.